All right, hello. Yeah, just a couple minutes late. It's not too bad. And this is gonna be another live stream, kind of working on well, in this case, on a C group related issue that's been open for a little while. I actually mentioned it in a previous live stream. Anyways, in general, what I'm doing lately has been just burning down through all of the issues related to Incus 6.0. So Incus 07's been tagged 2 days ago and should now be used by quite a few of you. And the plan is to try and keep the delta between 07 and 6.0 pretty small. So just solving a few, like adding a few minor features, fixing a few bugs, that kind of stuff. And then the current plan is for releasing 6.0 on Wednesday next week. That's also like behind the scenes. There's some more things kind of going on with those LTSs. We need to also tag LexCFS and LXC. LexCFS has been tagged as of yesterday, so we've got LexCFS 6.0 and actually an update to the Incus 07 package in my repository coming out later today. It's gonna bump people to 6.0 as well for LexCFS. Then LXC, there's a bit more work needed there as far as cleaning up a bunch of bugs and that kind of stuff. Current hope is to tag LXC on Tuesday. So trying to get both of those out of the way and then be able to do Incus. All right. So for this live stream, the issue I want to look at is this guy, which is extending our current limits memory swap parameter config option to allow bytes amounts. So right now, the logic, and we'll go into that in a tiny bit, but the logic for it is a basic Boolean. It just lets you choose whether to expose swap or not to the instance, the default being that you do get swap being available. And when that's true, then the kernel is kind of free to swap you whichever way it wants. If you set false, then the kernel gets configured in a way that should not allow any swap whatsoever, and also changes the swappiness to make that extra unlikely. That's basically it. But the idea and what we'll try and implement today is being able to set limits memory to say I don't know, 512 megs, and then the swap value to 256 megs. And effectively see that that instance now having about half its restriction as proper memory and the other half as swap. Again, you don't have all that much control at the end of the day. The kernel does control a bunch of that, but that's the general idea. All right. So first thing first, we're gonna need some test environments. There are two different versions of cgroup, cgroup 1, cgroup 2. And even within cgroup 1 and cgroup 2, there are a bunch of different ways to do some of those limits, but we're just gonna take stock Ubuntu and go with that. I actually did have Kirk Oleshkin respond to the announcement for this live stream on Twitter, mentioning that he's seen systems, cgroup 2 systems that are lacking the swap tracking files. And yeah, I definitely believe that. I think I've seen some of those systems. Older kernels definitely did not have any kind of swap control that came in later. But even then, some distros might have different configs. There used to be boot parameters as well to turn off swap accounting, because that used to be considered as resource heavy. So exactly what's available where kind of varies. And as always, like for that kind of stuff, Incus performs some detection on startup and returns an error if you're trying to limit something that can't be restricted. So let's switch over to a terminal. And the first things we'll need to do is actually create an environment where we can test this stuff. So lately I've been creating a bunch of projects for the stuff I've been working on. So I've got a lab for LVM cluster, a lab for then interconnect. So let's just do another one here for, let's do lab C group. Default settings is fine. Then we'll switch over to that one. And what I then do, I do like having separate profiles, but I also usually just want the same thing as from my main default project. So we can do this to effectively copy the content of the default profile over. which is just kind of basic config. And with that in place, we can start creating a couple of instances. We'll do VMs. So one called cgroup1. Maybe give it a tiny bit more memory since we're going to be testing memory limits. There we go. And we'll do another one for cgroup2. Obviously, they're both going to boot in cgroup2 mode here, but then the cgroup1, we can go and change boot parameters to have it boot with cgroup in cgroup1 instead. So if we look here, this is a cgroup2 tree, so we need to go and change the kernel boot parameters for systemd dot. I don't recall. Do I have a man page somewhere for systemd? Because it's unified something, I'm pretty sure. Yeah, unified cgroup hierarchy. There we go. I mean, that's something that's actually gonna go away or has gone away by now, but should still work on this release. Unified cgroup hierarchy false. I think we'll do what we want. So unified cgroup hierarchy false. Update grub and reboot. And now hopefully we'll have two VMs, cgroup1 running in cgroup1 mode, cgroup2 running in cgroup2 mode. The next step is going to be actually getting some swap in there because our default image doesn't have any, but installing ZRAM should do the trick. That just compresses some memory into swap. Okay, so that's rebooted. Let's see if we're in cgroup1 mode. We are, cool. Okay, so that's good. Now I also want to see if the memory controller has swap control. Yes. So we've got memswap here, memsw, oops, this guy. So having those files around means we can actually mess with swap limits, so that's all good. As I said, there's no swap on that system, so we just need to set up some compressed RAM. Don't recall if it turns on automatically, it does not. Let's just see if it does on reboot. I'm pretty sure I could just restart the ZRAM systemd unit, but I don't want to get into a case where that VM reboots for some reason, then I don't have the swap, and then I get confused for half an hour as to why my swap limits don't work. Okay, so that's not good. Why didn't it do stuff? Okay. Oh, okay. Yeah, I know what's going on. The kernel in those in our images don't include all of the modules by default to keep things kind of light, but that means that the ZRAM kernel module is also missing. So I'm just going to install Linux generic in both of them. Also install ZRAM in the second one, then reboot them, and they should come back with some swap. I believe it does something like half the memory or quarter of the memory is compressed as extra swap. Doesn't really matter. We just need to have some for testing. All right. So most installed in the first one. That kernel pulls a bunch more stuff we don't actually need, like thermal management and all that kind of stuff. Doesn't make sense for VMs. I could just install just the modules extra package. That would be that would have been lighter, but I never remember the exact package name, so this is easier. All right. So rebooting this one, and hopefully it will come back up with some swap this time around. A few seconds. The second one should be almost done. Installing things. Yeah. Okay. So just install ZRAM config. There we go. And reboot. Okay. Yeah, the first one is back, and we've got swap. Yay. So about it actually took about half the memory in this case. So we've got about 4 gigs total and 1.9 gigs of swap. Okay, and exact same setup in the second one, so we're good. Next, we need to actually install Incus itself. So I'm just going to install curl so I can fetch the install script. Oops. Again, so it's pretty convenient, like a convenient script that just sets up the right package sources and installs everything. Not something that's particularly documented because I don't like telling people to pipe shell scripts into a shell, but that's something that I use both for development and in our tests to just make things a fair bit easier. Question about the cat. Yeah, he's currently sleeping in the other room. We'll see if he makes an appearance. I might come and drag him in at some point. Sure. Yeah, I can copy paste. So the question around the link to the script, I can paste it. Again, not something that you should really be doing in general. Like we see a lot of software publishing instructions that are effectively that. That's a bit terrifying because it literally runs unknown code as root. You should at least download the script and look at it instead of just blindly running it. But yeah, in this kind of dev environment, it's great. Cool. So that's Incus installed in both of them. We don't need anything special for storage or anything because we're just going to be messing with memory. So Incus admin init auto will do. Okay. And let's launch a container. So let's do U1 in both of them. That way we've got a kind of full user space to mess with as well. Like I could do Alpine, but Alpine gets a bit annoying if you need to actually look at anything inside of it. So let's do Ubuntu, and then in there we should see all of the memory is available. You should see pretty much the same thing in both. Yeah. All right. So we got that stuff in place. Now let's just apply a basic memory limit to both of them. I'm going to go with pretty low limits because part of the testing for this feature is going to be actually making sure it's enforced, and it's a bit annoying if you've got a lot of memory you need to burn through. I actually meant to check if StressNG had an easy way to kind of just run a system out of memory, basically. That would have been convenient. I might check that in a few minutes. All right. Cool. So if we just do a memory limit of, this is almost nothing. So let's do 256 megs. And then that way we can do half of that as swap once that's in place. Okay. So. So here we can see a bit of a different behavior on like CFS side. That's again because of cgroup v1, v2, and how things actually kind of work behind the scenes. Cgroup 2 is generally kind of more flexible, so we can see the same limit applying to both. For the on cgroup 1, because the limit is effectively combined, so you've got, it's not just a cgroup. It's not just you put a limit of 256 megs for memory and then 256 megs of swap. What you have to do in cgroup 1 is say that your total swap plus memory plus swap is 512. When you do that, then we have no good way to really expose it to the user, which is what you get here, because even though the limit for the instance is supposed to be 256, and then 256 of that can be used, well, extra of that can be used by the swap. The kernel can do whatever it wants, so we'd risk, like, with the old way of doing reporting on like CFS, we were effectively getting a used amount that was larger than the total, and that was obviously causing a bunch of issues, so we had to kind of take a step back, and that leads to that weird reporting there. All right. I just see a question around, before deleting some of the containers, I purged the Incus package. Then the interface is not deleted. Yeah, I mean, if you just purge the Incus package, then nothing's getting cleaned. Like anything that's remaining as kernel state, so network interfaces, AppArmor profiles, and that kind of stuff is all gonna be sticking around. There's no good way to clean that stuff up other than deleting that stuff beforehand from Incus. If you're gonna go full on deleting and purging the package, reboot afterwards. That's pretty much the best recommendation for cleaning things up. All right. So like memory reporting and stuff is really confusing. We actually have a reasonably long README in like CFS trying to explain what we do. Yeah, short version of it is there's no good way to do it. So that's the behavior we have right now. Now let's see if we go and we do memory swap false. So we on top of the memory limit, we also turn off the swap entirely. Let's see what we get then. Okay, 0, so that's expected, and 0. Okay, so that part works fine. Effectively, in that case, it's like a hard limit, and swappiness is set so that we don't touch the swap. Okay, so that's all good. Now, what we want to probably make sure is if we turn that stuff back on, see what the memory limit actually ends up looking like. So that's where having maybe stress, I'm hoping stress-ng can do it. Having something that can eat up a bunch of memory easily would be nice. Like there are other ways, like usually would create like a temp-fs and then put some files on there. The problem with temp-fs is that it's probably not the easiest thing to swap. So it might just trigger an out-of-memory kit or something like that, which is not what we want. Anyway, so let's see, stress-ng. I don't recall how that will work, but hopefully, so we see VM as in virtual memory. Spinning. Okay, allocate n bytes per VM worker. Okay, so that should run the machine out of memory very easily in its default config. Is there anything else memory related in there? But I think the VM stuff will probably do, because the rest is really syscall related, as in stress testing, malloc, and some of the other syscalls. All right, so let's try maybe the VM stuff. So VM number of workers on anonymous mmap, default buffer size 256. If I just do 2 of those, that should run us out of memory pretty much. Actually, let me get a second shot in that one to just see what's going on. Okay, Incus info U1. What's the memory? Memory current 149, peak 256, swap current 23. Okay, so we've not run out of memory. Is that growing? Okay, so we are at 255 now, which is about as much as it's going to be able to allocate. Did we trip anything? Nope, no out of memory, no nothing. Okay, but we do see the memory usage up there. There's a question around the behavior for limits memory swap. Yeah, so there's no there's no real fine-grained control on the swap behavior. So what the limit to 0 does is effectively it configures the kernel so that there is no configured extra memory with swap. So effectively the total memory amount and total memory plus swap is identical, which in itself doesn't mean the kernel can't swap some or even all of the memory if it wanted to. What we do on top of that is that we change the swappiness to make all of those processes extremely unlikely to be swapped in the first place. The combination of the two usually means that you remain in memory and not in swap, but if there's sufficient memory pressure on the system, or if you've got multiple containers with the exact same config, then some of those might still end up getting swapped rather than trigger an out-of-memory kill. The other thing that we do is we do always set a soft limit at 90% of the hard memory limit. So the kernel should already be trying to limit memory consumption before it even gets to the maximum amount to, again, try and avoid some of that. But yeah, there's just not super flex. It's not, we don't have as fine-grained control on memory as we would like sometimes. Okay, so this seems to be working. The thing is running. It's using 255 megs. And we could try running more, but it's most likely it actually does detect it's about to run out of memory, and is not just tripping the limit and getting a memory killed. So yeah, we're back to 255 pretty much immediately. Okay, so that's good. It actually went down and a bit back up now, but that seems fine. Just for kicks, I want to bump the memory limit up a bit to see if, given a higher memory limit, if it immediately scales up. Doesn't look like it does. I mean, it went up a bit, like we're 261 now. But we probably need to restart the thing. Let's see. I want to see if it would go past it and to a higher amount. Yeah, it does. Okay. So we go 300-ish. Definitely past the 256. So that's good. We get to use that later now. Okay. So let's bring that back down to 256. And just make sure that the behavior matches on cgroup 2. Oops. Incus info U1. Okay, current memory usage 230. This one is a bit different. Looks like we're using more swap. From what I recall on the previous one, we weren't really doing much of that. Swap, yeah, swap usage was much lower on cgroup 1. So that's interesting. Again, we don't really control any of that. But we can see that instead of going straight to the 255-ish and sticking there with a tiny bit of swap, it actually swaps a tiny bit more with a combined space that's actually exceeding the limit slightly. Anyways, seems to be still roughly matching. There's, again, differences in how memory limits are applied with V1 and V2. Not really from our point of view, like we pretty much just set the same bytes values. But then how it's actually enforced at the kernel level, what's accounted towards which, and how it's split between the two. So that's fine. Okay, so that just shows we've got 2 test VMs with a test container in each that can do memory allocations and seems to be generally behaving. Now we need to go and change the logic so that it's possible to pass integer values to the swap limits, and then have that be written hopefully correctly within the cgroup tree to just have it behave there. In general, we should be able to actually look at the limits. Not directly there. We're gonna need. All right, let's put it not in the container. Okay. So if we look at this current setup, memory, there we go. Memory max, so that's 256. Memory swap max is also 256. That's where things are a bit confusing, and we'll have to see exactly how that behaves in practice. Because like it's always kind of unclear whether with that we currently have 256 usable and 256 can be used as swap, or 256 usable and an additional 256 can be used as swap. The behavior so far with the tool definitely implies that it's the former, but again, kind of confusing. Let's see, so memory on this one, memory, oops, the limit in byte is what we want. So 256 and combined. This one has the weirdness for the combined value. Okay, let's go look at the Incus code and try to change those config keys to be more flexible. Okay, this is an unrelated branch, so I should go here. pull the current state of master. There we go. And we'll make a new branch called cgroup. Oh, already exists. Okay, well, reuse that branch then. Come on. Okay. All right, so there's nothing in that branch. That's fine. I will just use that now. So if we look for the limit, so limits memory swap, there we go. We can see it's defined in this file. So that's one place where we need to go do a tiny bit of editing, because currently it's defined as a Boolean. That needs changing. So limits.swap, memory.swap, sorry. There we go. Memory.swap should effectively be processed the same way as memory itself is. So if we go look at limits.memory, okay. This one actually has a reasonably complex function to validate it, because it can do percentage based as well as fixed amount. I don't think we're going to be doing percentage based. That seems like potentially problematic, because then people are going to get confused as to whether it's percentage based of the total memory of the instance's current limit or of the system swap. So I'm just not gonna bother and just do only fixed amounts on memory swap limits for now. Which means we can do that stuff in a slightly easier way. Do we have a validator? There must be a validator that already does the parse byte size string stuff directly. Let me check. Yeah, definitely is, since we're importing units. Okay, so if we do is size, then it validates that it's a byte size. Okay, so we can just do is size as the new validator for the swap. So it's actually bool, or actually, how do we define that? Let's see. Yeah, okay, let's just turn it into a string. We're gonna have to be a bit more specific in the description. So string default is true. Okay, and the short version is whether is okay. Let's just turn that into control swap usage by the instance, and then in the long description I'm going to go into more details. All right. This can be used to limit the amount of swap memory that can be consumed by the instance. The value can either be a Boolean to control general swap general access to swap, or a bytes value, total bytes value. Okay. And that should do the trick. And here is where we need to make changes. So it's optional and validate dot, I think we've got or now. So it's either a bool or validate dot is size. Okay, so that should work. Just see if that compiles. Looks like it does, so that's good. Question around whether there are scripts for ZFS and the Linux packages. I think there might be. Let's see. I would expect them to be Linux-stable or not. Kernel stable. Yeah. Okay. So kernel stable works, and ZFS stable, and ZFS stable works too. Yeah. So there are scripts for those two. All right, so this is built. Obviously, it doesn't do anything useful, but it does at least let us set a value now. So that's nice. We also need to actually add an API extension for this stuff, so let's do that. What's instance memory swap bytes? Okay, this extends limits.memory.swap to allow for the total limit in bytes. Okay, instance memory swap bytes. Okay, version API. Okay, so that just makes us an API extension. Okay, and commit both of the files we just changed there. What did I mess up now? Oh, it's internal version, not internal API. All right. Then this is the validation logic, so that's gonna be internal instance update validator for limits memory swap. Okay, and this then lets us update the metadata that generates the documentation, so I need to update that. So that's kind of a nice thing with a bunch of that stuff being effectively generated, like the code now generates the documentation for those config keys. I don't need to go and update that. I just need to go through this. And now we've got the updated metadata for the config keys. There's a standard commit message. I think it's like update config maybe. What is it? Yeah, update configs. Okay. So let's just do update configs. All right. And okay, so that's all the validation bits and documentation, all that stuff in place with an API extension. So now we need to actually have it do something. So again, if we look for limits.swap, the good thing is that this is going to be a container only thing. So that kind of limits the number of places we need to go modify things. And if we look at the files, so we've changed the API extension, it's done. Config option is done, config is done, and configuration is done. So there's just one file left to actually try and plumb that stuff through. So if we go in here and we look for limits memory swap, it's going to be present in two different places, both for initial startup and for live updates. So we can effectively update just the initial startup one until we're happy with the behavior, and then go and mostly duplicate the logic into the live update case. If we go back to our example here, we should actually see LXC Incus, so the runtime data. All right, so U1 config there. So that's the default config. Let's see what we've got for cgroups. We've got nothing. Huh, I thought that the memory was gonna be applied through that. Let me just restart it. Maybe we just never restarted it after. Yeah, okay. So all of the demo I did so far was all live. This is with actually restarting it. So now we get the amounts that are pushed that way. So we can actually see 256 for limits in bytes, 241, which is likely 90% of the 256, and then memory swap, which I'm not even sure why it's set to double. Like if it was set to false, it should be identical. Yeah, I guess it's just a compromise of not really being able to have too much control on that. Because that in theory does let you exceed the total memory limit, which is not what we want. What we actually want is to have the ability to use swap, not exceed the limit. I might actually just fix that. Like effectively the difference I would expect to see, I think, on cgroup 1 is if swap is enabled, we should see the 256 value for both of the initial files. So both the memory and the memory plus swap. And then soft limit is 90%, that's fine. What we should not see is the swappiness setting, because that's effectively what we use to turn off the swap. So if we set swap to false, and then if I restart that instance and I go look at the config again, now we see swap in as 0. Okay. So let's change that behavior first, because I think that's incorrect. The memory swap limit in bytes should just match the memory limit effectively always, until we are, well, actually even when we allow the swap control. Like this, the fact is on v1 we just don't have bytes amounts control, so we're gonna have to focus on v2, I suspect. Let's see. And I'm not even sure exactly of the v2 behavior. It's a bit confusing, and I'm not actually I think I'm gonna be discovering some stuff in this very live stream for how that stuff actually works, but I don't remember. Like effectively with v1, I know for a fact that we've got those two limits. We've got the total memory limit and we've got the total memory plus swap limit. If we set it to both values to the same thing, it still means you get to. It's possible for all your memory to be swapped. You don't get to control that. That's what the swappiness lets us kind of do as a boolean on and off. If we set the memory swap limit higher than the normal memory limit, it would allow you to exceed your memory limit by consuming swap, which is not what I think most users would expect. Or if that's how it becomes, then we need to change a few other places within Incus, so that when we set, say, a project memory limit, that it considers the total of both memory plus swap for the limit. That's kind of what's going on in my brain there. But the reality is that cgroup 1 is going away, so I don't want to base any of this on the cgroup 1 behavior. I would much rather do it, much rather look at the cgroup 2 behavior, as that's kind of what we want moving forward. And if swap limits in bytes don't work with cgroup 1, I can live with that. So, speaking of cgroup 2, let's just go look at what that looks like. So if we go grab cgroup to in run incus u1 lexicconf there. Okay, so this one we see high is the equivalent to the soft limit, so that's fine. That's the memory pressure threshold. Memory swap is the memory max is the total memory, and in this case we've got swap max set to match. What's actually kind of interesting to maybe see how that stuff works is when we start an instance without a limit. Is Incus using cgroup 2? Well, it depends. If you're on the cgroup 1 system, we're using cgroup 1. If you're on the cgroup 2 systems, we use cgroup 2. But yeah, it's using cgroups for containers. 2204 U2. Okay, so if we do a container with no limits, that can be interesting. Let's see, to look at what the values look like inside. Okay, and let's do it on cgroup 1 as well. Okay, so let's go look at memory max. Memory max should just say max, and swap also says max. That's fine. Memory current, swap current. So that gives us our kind of current consumption on both. That's fine. If we go look at U2 on cgroup 1, so memory limit in bytes, no limit. Mem swap, limit in bytes, same thing, no limit. So that's kind of the stock behavior. Now let's see. I would really have liked to have a good way to stress test both the normal memory usage and the swap usage at the same time to get a better feel for how that stuff works, to be a bit more confident about the approach, let's say. Anyways, because this one currently, so there's still no new code there, but this one, well, actually no, U1 is the one I want to look at. Its current memory limit, so the max memory is 256, and the swap here is 256. what I kind of want to try now is running the stressor in there to make sure that our current logic even makes sense. It's quite possible that it actually works the same way as on cgroup 1, and that we'll need to do something slightly different in this case. So let's try to stress it again a bit differently. So I'm going to go inside, well actually no, I'm going to go in the cgroup tree here. And the good thing with cgroups is that most of them are just file-based, so you can directly mess with them. So if we go memory, well, not memory, actually we need lxc.payload.u1 and memory max. Yeah, so that's where the limits are currently set. Okay. Now if we go, just checking I'm in the correct one, yeah, and we run stress ng, let's spawn a bunch of them. Okay, so memory current, swap current. Okay, so it's using a bunch. We're effectively at the high threshold on the memory. Yeah, pretty much bang on the high threshold, just slightly past it. And the swap is seeing about 60 megs usage-ish. Okay, so that currently, like the total exceeds the limit. Now the question is, if I stop that and I bring the swap limit, so the swap max down to 0, let's see what happens. Well, what happened is that the instance died instantly. Oh, it's because I did memory max. I'm stupid. Okay, never mind. Set it back up. Okay. Hopefully it reuse the same cgroup. Let's see, memory max. So that's what happens if you put your memory max to 0. Instant out of memory kill, most likely. Yep, instant out of memory kill. So that's good. That works as expected. Okay, I'm back in. Let's look now. If I do memory max is set, swap max there. If we bring down the swap to 0, okay, and we run the stressor now. Memory current, okay. So we see the memory going pretty much to the max. So to me, it definitely looks like this is actually behaving as additional storage in both cases. Let's look at the docs, because that's what someone's supposed to be doing. Problems that I did already, and it wasn't exactly very definitive in the way it was written, but maybe I misread it. So let's look, memory controller, cgroup 2. So memory max, that's what we set currently. High is the memory throttle limit, that's fine, we set it. Memory max is the memory hard limit. If you reach that, triggers an out of memory kill. Okay, that's fine. We understand that. Then swap, it's total amount of swap currently used by cgroup and its descendants. Swap max is the max, the swap usage hard limit. If a cgroup swap usage reaches that limit, memory will not be swapped out. Memory that's already has swap slots allocated can continue to be swapped. Default is max. Yeah, that doesn't really clarify whether it's a subset or an additional allocation. Now the behavior so far definitely looks like it's an extra allocation. Swap historically is bad reputation, blah, blah, blah. Okay. Because swap is slow, the team disabled swap, editing swap max to 0. Yeah, that doesn't really clarify things. But the behavior of memory plus swap being able to exceed the limits on both v1, v2 definitely suggests that this is additional allocation, which kind of works in the model in that it's the same thing as in cgroup v1. Probably makes sense bit more annoying on our side because most users would kind of expect it to work as a subset, and it doesn't work that way. But we can work with that. So anyways, the first thing I want to do is actually having like changing the logic so that the swap on-off flag does not grant you additional memory usage, because that feels wrong. Out of the box, it should really just tweak the swappiness and not touch and not grant you additional memory usage. And then we can make the limit memory swap actually grant you additional memory that's gonna come from the swap. And that should line up with what the kernel effectively offers. So let me just check the chat. There's a few questions in there. So Incus, yeah, okay, given the RAM, the swap is available for %, would it be better to have? You can't configure, so there's a question around ZRAM, ZSwap, and them like running on the host or in the container. The container cannot have their own swap. They can't create swap space. They can't set up ZRAM, any of that kind of stuff. That's done on the host. So in this case, my cgroup 1, cgroup 2 instances are VMs, which is why I had to install ZRAM in there. But the container doesn't get to allocate, doesn't get to define additional swap space. I'm also not going through Meta's UMD at all. This is not UMD, that's the cgroup 2 documentation from Meta. Tijan Heroes, the maintainer for cgroup and the creator of cgroup 2, works at Meta, and that's why the cgroup 2 kernel documentation is hosted as a mini site on the Meta thing. I mean, technically, there's a text copy kind of in the kernel, which is what's listed here. But it's roughly the same thing. So if we go look swap max, let's see, maybe it's actually clearer. Read write value, which exists on non-root cgroups, default is max, swap usage hard limit, cgroups, it's effectively just saying the same thing, which is again not super clear at first read as to whether it works as a subset or an extra, but all signs point towards it working as an extra. So anyways, let's go on with that. First change to do is just turning swap on or off should not grant any additional space. So let's just fix that bug first, and then actually allow setting bytes value in that thing. So memory swap, limits memory swap. There's effectively a call that's done, which is we've got set memory limit and then set memory swap limit. So set memory swap limit, we pass value int. Yeah, so that's the logic that's wrong. Just making sure that there's no other call to that stuff, and we just need to fix those. Memory swap, okay. And here, I mean, we jumped a bunch, so we're probably in the update code. Oh, we still in startup. That looks like startup. Yeah, it's still in LXC, okay. Okay, yeah, that's the swappiness call. All right, that makes sense. Okay, and then we swap a whole bunch and we end up in the update call. Okay, cool. All right, so this is the logic for on startup. It effectively checks if we've got soft or hard enforcement. Only under hard do we actually do anything useful. If we've got, if we're under hard enforcement and memory swap is supported, then okay. So that's this branch. I'm just figuring out something. Yeah, that's weird. I think we might set the limit twice, maybe. Because I'm seeing the enforcement for when swap is supported. I don't know what happens to normal memory limits if swap is not supported, because that's a different matter. And all of that is already under the check for memory limits. So do we actually do a set memory limit? Memory limit in the event that there is no swap support? Or do we just not? Okay, it's this, never mind, I just misread it. So that's this else statement here. Okay, so if we do have swap support, then we always apply the memory limit itself. I'm not sure why we're doing this exact same thing twice. Let's simplify the code so I don't get tripped by this again. This should have gone here. So always apply the memory limit. Okay. And then we've got the if the swap is swap limits are possible, and we've got swap disabled, and swap is set to a value of 0. What we actually just said is that this should always be set to a value of 0, so long as it's a Boolean, effectively. And then we'll only put a different value in here if the user specifies something else. So for now, this is fine. And then we set the soft limit 90%. Okay, that's fine. Let's just put a fixed me here. And support. Yeah, so that's where we're going to need to put that later on. For now, we just set the swap limit to 0 always if the kernel supports it. Simple as that. And then later on, there's the check for the swappiness, where again, this time if the swap is disabled, we want the swappiness set to 0. If it's not disabled, then we calculate a priority thing. Okay, so that's fine. That actually fixes the current behavior of granting more memory, basically always, which is definitely not what we want. So that fixes that small bug. And then we can finally add the additional memory allocation that comes from granting some swap space. So actually, I should, as I mentioned, that logic exists twice. I only fixed one of them, so let's go fix the other one. Yeah, memory swap. So that's still swappiness. Next up, there we go. So revert memory. Okay, that just reverts the old values. That's fine. Reset everything. So that just clears everything to -1. Set memory limit, set soft limit. Okay, and then we set the new limits. So we effectively have the exact same logic again with this exact same bug again. And this stuff should definitely be refactored at some point. The logic is slightly different, which makes it a bit annoying, but so much of it is identical that it's kind of frustrating. So again, put the memory limit in place always. Don't need this chunk anymore. And here, as I said, this should always be set to 0 in that case. So let's do that. And here we'll do the byte support. Those fixed me's I should actually remove for now. Otherwise, it's going to make committing this work a bit harder. So let's just do that. Okay. So that should fix the general behavior now. Let's just build it. There's a memory swap declared not used one here. 4528. Yeah, I'm gonna have to put it back afterwards, but oh well. Just checking that the delta and stuff makes sense. All right, so okay, removing all that logic. Just if supported, set the swap limit to 0. Same thing here. If supported, set it to 0. And yeah, on startup, the memory swap is not. Actually, no, it's on update. That's interesting. Memory swap is no longer needed. That's fine. Oh yeah, because we're just using value int here. Where were we checking? I guess memory swap is still used by something on startup, which is odd. Let me just check where. So I was expecting that variable to be gone in both cases. That's why I was looking around. I was a bit confused. Configure swappiness again. Okay. So if it's false. Okay, so why? Okay, now I'm confused. The update case should have the exact same logic. Why isn't it using the same variable then? So let's go look. Sorry, I'm a bit all over the place, but that's code I'm not super familiar with. Okay. Oh, because it's pulling the swap stuff again. Oh, it depends on the block memory. Okay. Where was it getting? No, I'm pretty confused because it should, like, I don't know why it's pulling that key again here. That should have been here, as it used to be, and then be used in both cases, right? Okay. Yeah, it was just a duplicate allocation. Okay, cool. So that makes sense. Fixes that bit of a headache I was getting by being very confused as to why the two chunks were not matching up. So that's why it was just that variable was defined twice. The priority, it makes sense to only put in that case, but the swap itself should have only been put once. So this is a small bug fix. We're going to be committing that as Incus D instance LXC fix default swap allocation, allowing swap usage should not result in additional memory being made available to the instance. So limits memory swap should only control whether the instance is likely to get swapped through the swappiness control. Okay. All right. So that's that bug fixed. We could push it to the instances and check, but might as well just add the byte support and then test the whole thing. So, byte control. If we go again, look at swappiness stuff, that gets us in the right ballpark, and it's effectively here. So now, if we're dealing with a boolean, we should just we should still do the swap limit set to 0. Otherwise, we should read the value in bytes, turn it into bytes, and shove it in there. I'm trying to figure out what's the easiest way. We could do like a is true is false type thing on the value, but yeah, I guess let's do that. So let's validate as it's in util. That we got that? Yes, util. Okay. So util is true or empty. The value, which is memory swap, or is false memory swap. So effectively, if it's empty or if it's a boolean, then we should go here, and that also hints that the default is true. And then the remaining valid cases, those are gonna be the integer values. So additional memory as swap. Okay. And just checking here. So if it's false, then we switch openness to 0. All other cases, we set the priority. Okay, so that remains perfectly correct. So it's just here now that we need to actually pass the limit, which is done this way. We can just reuse the parser. That turns our strings of bytes. So that's either like a fixed byte number or something with a prefix of like megabyte, maybe bytes type stuff. So that passes that into a straight byte count, which is what we need for the kernel. And in here, this is going to be memory swap that we pass in. So just pass that stuff in. And now we've got the integer value. Actually, let's call that swap int, so we don't just override the other value and cause issues. And then that goes straight to the kernel as a swap limit. Okay. So that's basically the new logic for that. I'm just gonna take this entire chunk because, as mentioned before, we're gonna need to copy paste it further down. Just want to make sure that the code builds first. Yeah, it does. Okay, cool. And then we can go straight to the other copy we need of this mess, which is in here. Max priorities. Okay, so that's the swapiness itself. Memory limit. Okay, that's the equivalent function. So this here. Just fixing the embed by hand. There we go. Delete that. Okay. Let's build this stuff, and it's not happy. 4638 return value. Okay, just wants the error. That spot. It's fine. And I think on error we need to do revert memory. Yeah. Okay. So let's do that as well. Okay. All right. And then the question will be around memory accounting within projects. I'm going to want to make sure whether limits memory swap is a key that we consider to be safe currently. If it is, then I'm going to have to spend some more time fixing that logic. If it's considered to be unsafe, as in you need low-level privileges to be able to set it, then it's not as concerning because normal users with a project limit allocation won't be able to make use of that key to begin with. Actually, let's go check that real quick. So limits memory, I think it's in, it would be an internal server project that we've got those things. Project permissions, sure. Okay, so limits memory, what do we have in here? Okay, all aggregate limits, that's fine. Is low level option forbidden, return true if low level VM option is forbidden. Okay, that's VM stuff. Limits memory, okay. So that's the project limit still. Aggregate limit config. Okay, so I kind of want to look, we've got a config for RILXC here. Yeah, there we go. Limits come. So I'm pretty tempted, given what we've seen so far, to add the swap stuff as low level. So limits dot memory dot swap is now a low level key. So that basically means you won't be able to go and set that in a restricted environment, which makes sense because if you can force yourself to not use swap, in some cases you could cause memory pressure and cause issues. And same thing now, if you can grant yourself more memories by setting a bytes value, that's no good. So let's just put that in place. So we want to commit the internal project, server project is called. Oops. So incus the project, restrict access to limits memory swap. As limits memory swap can grant additional unaccounted memory, limits it to those who can use low-level LXC options. Since those users can already do whatever they want, so that's fine. And then that's the logic that actually adds the bytes values. So incus the instance LXC, add support for swap for extra swap in bytes, and that's then the 541 is the issue. Okay. All right, so in theory that's all the code in place. Now the question is everything clean, and then does it actually work? I'm reasonably confident it will, because we didn't need to go mess with any of the logic within the C group logic itself. It's effectively just from Incus's point of view what it should do with each of the values. The current logic was, looks like it was wrong, so that's been fixed now. To just only tweak the swappiness based on the Boolean flags, and for everything else, we read the value in bytes, and that becomes an extra allocation. So that should all be fine. Again, just making sure the code passes all static analysis. Then gonna push it to the two VMs, restart the containers, and kind of make sure that the values that are applied make sense. I don't necessarily expect LexCFS to make sense. So the free value might look really weird. That's just, again, because it's difficult to figure out exactly what's possible, what's not, based on what the kernel reports. Just like those kind of aggregate things are annoying to try to keep track of. And LexCFS effectively just makes the best guess, and in some cases will just not show the swap at all, even though you might have some stuff getting swapped. Anyway, it's purely cosmetic. The actual limits get applied by the kernel, and that's kind of what matters. All right, come on. Okay, so static analysis is all clean. Just building new binaries, pushing that, and then doing some testing. It was a really interesting one. I wasn't completely sure what direction things were gonna go as far as the enforcement on cgroup 1, cgroup 2. I was hoping for the subset type limits. That would have been much nicer. But we can also work with the things going the other way around as an extra allocation. It's just a bit more annoying to deal with. So this is built. Go bin Incus D, and we want to push that to cgroup 1 and push it to cgroup 2 as well. There we go. In here, now I need to get out of those containers. Oh, I've been running that memory stressor for this whole time. Didn't even notice. Oops. Incus D of Incus D. It's the kind of thing when I'm on my desktop instead of my laptop, I really don't notice if I've got stuff running CPU in the background, or in this case, really hammering the memory. I think on my laptop I would have started to feel the heat. So restart Incus and restart Incus. So now in theory we've got a new logic in place. Let's see what we have on U1. So memory limits right now is 256 megs and swap is not allowed. Okay, so if we restart U1 with that, I'm gonna just check the raw values to make sure that they are what I expect. So yeah, we've got the same value set as both memory and memory plus swap, and swappiness is set to 0. So that's the case where we try to prevent swap usage, so that's fine. Now if I unset the key, configure, unset. Okay, and I'm still going to do restart. The live update does work, but the restart lets me look at the config every time, which is nicer. Okay, so swappiness is gone. The limits are still there. That's fine. Just want to check how it's reported inside. Okay, so as you say, like this looks kind of wrong because you see the container is configured for 256 megs of total memory usage. But LexCFS has to lie to you and pretend that you also have 256 megs of swap, even though you don't. You've got a cumulative 256 of both. That's because if we don't do that, then what do you report as what? And then you get into the weird case where you could have your usage exceed your total in some cases. So anyway, LexCFS kind of lies to you, but the limit as applied in the kernel makes sense. It's fine. All right, and then the next thing to do now is actually increase that limit. So limits memory swap. Oh, that might actually fail. Let's see. Just thought of something. Config set. Oh, no, okay. I was thinking it might fail because we do some amount of checking of those config keys on the client side. And I didn't refresh the client, only the server, but I think the client just checks that the config key exists, not do anything more than that. So anyway, it's fine. So that's now set, and let's restart. And what we should see, yeah, that looks correct. Okay, so memory limit 256, memory swap is 400 something, which is the total of both limits, and soft limit is still 256. So you get to swap, but you're still gonna have a soft limit kind of nudging you not to, which is fine. And there's no swappiness or anything in this case, so that's good. That makes sense. Now let's see what it looks like inside. Yeah, so that shows the 256 memory limit with the swap being maximum 384. In theory, it's actually it would be possible to not use any memory but only use swap, which is why LexCFS reports it that way. That's correct. Now let's go look at cgroup 2. We get the same behavior. Let's just look at the config first. Okay, so right now we've got swap is enabled, which there's not much point in actually having a config key in that case. U1, oops, there. Okay. And now let's restart it. So I'm restarting U1. Can I go look at its config, U1, lexicon, cgroup. Okay, so we can see no swap configured, so no additional swap configured effectively. Memory is 256, high memory is 90% of that, so that's what we expect. If we go in there, now the swap usage, and I think that's something we actually fixed recently, the swap usage is reported differently on cgroup 2, which looks kind of confusing. In this case, it's actually a case where we could see the used exceed the swap total. So that seems, yeah, I need to look at the logic in LexCFS again. I know it was a compromise for cgroup 2 because we couldn't quite get what we wanted. And that might just be it, where we effectively don't report anything on swaps. We just return plain zeros for all of the values because we can't really figure out what's used, what's not in a way that makes sense. Anyways, so the limits as they are pushed in do make sense. Now let's go config set U1 limits memory swap false. So that's the swappiness test. Okay. This is weird. Oh, hold on. I think that's a cgroup B2 limitation. I remember that being a problem for a while, where there's effectively no swappiness control. Did they introduce it now? Try max, high, current. No, I don't see any kind of swappiness stuff there. This is an older kernel, so I'm just gonna check it on my own system as well. So if we do a payload, whatever speed test, let's do it on. What do we have? Z-swap, okay. Yeah, no, same thing, no swappiness control. Okay, so that's why it's not there. It's because we just can't do it. That's still some of the rough edges with cgroup 1, cgroup 2, is that some stuff are just plain missing. And that would be one of those. So yeah, that doesn't work. Now, what happens if we set it to the extra space? So 128 megs, that should work at least. Now let's look at the values. And there's a warning, I believe, on startup that says that cgroup 2 is missing the swappiness stuff. Okay, so max memory 268, max swap 128, 256, 128, 128, and 90% for the high. So that's the values we'd expect. Just see how that's being reported. Okay, so that is now being reported correctly since there's dedicated swap space. So it does show 256, 128, and it will track that 128. I still think there might be a problem there with LexCFS's reporting because while there is a separate swap allocation and limits in place now, I could still see the kernel going past it. There's nothing that really prevents the kernel in theory from still, well, Actually, no, I think that's the part that's different with cgroup 2 from the man page we read earlier, saying that it will prevent swap usage. So that might actually be correct. On cgroup 1, you don't get to prevent the kernel from swapping that way, but here you might. Anyways, to be 100% sure of how that stuff works, I need to go dig in kernel code again, which I'm not particularly fond of doing for that part of the Linux kernel. But the limits as we push them now seem to make sense. It does allow that extra knob. It's only allowed for people that are trusted to do lower level decisions because that has a system-wide impact. And the things are put in place, and the default behavior for the swap looks correct now. So that should be fine. Might just want to run again, a quick stressor on both to see what that looks like now as far as the memory usage. So that's cgroup 2. Let's see. Okay, so that's effectively using a whole bunch of the memory itself, about to the 90%, and then hitting some of the excess onto the swap. So that makes sense. That's good. And if we go look at cgroup 1, do we see, does it report similar behavior? It's going to report a different amount, but yeah, 31 megs used. So the entirety of the memory is used, and the swap is slightly used. One thing that's interesting to see is that in both cases we set soft limits at 90%. cgroup 2 does a far better job at sticking to that limit, whereas cgroup 1 seems to go straight past it and hit, like, pretty much gets to the hard wall and then stop there. It still doesn't cause an out of memory kill, so that's good to see. But it also doesn't really respect the soft limit being put in place by instead of using all the memory and just like swapping immediately afterwards. I guess the soft limit might work better if no swap is in place, at which point it might actually trip and slow things down. But I think in both cases, when we were testing with StressNG here, like it just seems to go straight to it. I guess that can be useful for some people because you get a bit more memory out of it, but it's also always a lot riskier to be that close to an out of memory kill. Anyways, that seems good. Seems to be behaving. All the tests are passing and everything, so let's push that. Okay, and do compare. Do I have the cgroup tree in my history? I do. Allow byte values in limits memory swap. I also kind of feel better with this whole thing from the fact that it's restricted. So the fact that you need to have low-level LXC access to be able to configure your swap amount makes it a lot less problematic in shared environments. And yeah, that will make things easier, because otherwise we need to start counting both memory plus the swap together as the total memory, potential memory footprint of an instance. But then you also have the question of like, okay, how much swap do you actually have on the machine? Are you overcommitting your swap? How does that stuff work? Which you then need to track separately from the way we already track the memory for that. Just simpler to restrict it, and we'll see if there are users in a shared environment that actually do need otherwise restricted users to be able to configure how much swap they want. I very highly doubt it. And if that happens, then we can look at what can be done. But yeah, I'm feeling good with the limit in place there. So that's it for this one. That's one feature fully done with all of the paperwork and everything in place. So that should be pretty good. It's gonna go through tests. Hopefully it clears them and then can get reviewed. There was a question from Jared around like, how does writing over Incus D not crash everything? Well, it's because move in that case doesn't actually try to write to the binary. If I was doing like cat and then pipe directly into the target binary, that would just fail with the thing is currently like open and running or whatever it's called. Can actually try it out. If we go here, so if I did that, effectively that I would expect to see having a bad day. Yeah. So if I write to Incus being Incus text file is busy because it's actually being currently executed, so you can't go and modify it. When you move, what actually happens behind the scenes is that it gets deleted and a new thing put in place, at which point Linux is still, like, everything works with inodes on Linux. So the binary itself, the previous binary is still being used until you do the restart. We can actually kind of look at that. So if I just push byte again to cgroup 1 here. Okay, so in theory, if I use strace, we should see what's going on behind the scenes. So if I do strace of the move, Incus D bin Incus D. Okay. Actually, no. On the first time, it managed to do it in atomically in a single shot because it's on the exact same file system. So it just did a rename, which effectively does delete move kind of in one shot. I expect that if I look at my where is my Incus D? Okay, so that Incus D daemon here. If we go look at the binary that spawned it, that will probably give us some hints as to what happened. Yeah, there we go. So we can see exe here, which is a way to look at the binary behind a given process. It doesn't show that it comes from optincus bin incus D. It shows that it came from that path, but a deleted version of it. So that kind of shows you that it's still pointing to the previous version, and that's why it's not crashing. You can't actually modify a binary that's currently being used. That would get you the error you had that I showed earlier. And as soon as it restarts, then it actually reads the new binary. So that's how you avoid issues. It's not to say that this Incus binary is going to be very happy. Incus in many places kind of re-execs itself for sub-processes, and that's not going to work well in this current state. That's why I just do the move, and then I restart it pretty quickly, because if you just replace the binary and then you wait a few hours to do it, you're going to have a bunch of random things kind of fail. Like exec might have a bad day. I don't know. Let's see. If I do exec, does that work? Yeah, it does. Like there are a few things that wouldn't work. Like for example, I think if I was to do this, to actually remove the binary completely, yeah, then that works. If you swap it and you swap it with something that's not compatible, then you're gonna get errors. But by and large, you get away with actually putting the, if it's pretty much the same binary, that works, which is kind of funny for some edge cases. Like if you wanted to just test the exec logic and you need to fix that particular part, the re-exec, you don't even need to restart Incus. You could just swap the binary for a new one and just run through an exec again. All right, so that's it for this one. Actually, I'm seeing some red. Where's the red coming from? It's not documentation, it's a cluster test. Wow. That's probably going to be some kind of race. Yeah, it's failed in install dependencies. I didn't even run the test. It probably just failed to download OpenFGA or something. Yep, OpenFGA repository, there's an error. Okay, so that's not an actual failure. That's fine. I'll keep an eye on this and hopefully it gets merged soon. And I think that's it for this one. I said, like, there's a bunch more things that I'm looking at with release currently scheduled for Wednesday. The list of stuff for 6.0 is shrinking, but not super fast. So it's going to be a busy few days to get there. Some of that stuff might just not make it in 6.0 and just make it in like either 6.1 and then like port it to 6.01 or something along those lines. Also, the cat seems to still be sleeping. I didn't see any movement. So probably not gonna be in this live stream, or maybe I can go grab him. Let me go see how sleepy he is. Yeah, he wasn't too sleepy, so he gets to make a quick appearance. Come on. bit sleepy still. Yeah. He wants to escape, but not very hard yet. All right. Okay, I'll let you go. There we go. All right, so you even got to see the cat then. All right, so not sure whether there's going to be a live stream next week. There's definitely going to be a release next week, so you might just get the release video for 6.0 LTS, and then I'll do a normal live stream working on some stuff, maybe the week after or something like that, or maybe another Q&A or something along those lines. Anyway, thanks to everyone who's been watching. Hopefully that's been entertaining. Definitely, I learned some more things around that part of memory management on Linux, and got to do that change. The change in Incus itself was pretty darn trivial. It's mostly about like trying to figure out what the exact behavior is, because documentation is not exactly amazing around that stuff, and then driving it to actually implement the feature the way we want it. So again, thanks for watching. If you've got any questions, you can leave them down below. You can go in the community forum, and see you in the next video. Bye.